Hello, good morning, and thank you for joining me. It's April 23rd today. Another gray, kind of drab day outside. Yesterday was nice. Not so much today. So, first, let me just comment about all my confusions yesterday. When I'm working in my shop, and I'm trying to do these videos essentially live, although I do take breaks and go drink coffee and stuff like that, I, at times, can get into something which is confusing me and I can't unconfuse myself, and it's all going out on video and the like. The way I look at that, and I don't think I'm any different than anybody. I think everybody doing anything ends up in moments of confusion with misinformation and stuff like that. Maybe not all the puzzle pieces, whatever it might be. To me, it's all part and parcel of the same thing. It's not me trying to fix the radio, two independent things happening. It's really a combination going on where I'm trying to figure out and make the radio work, but I'm also trying to figure out and make my brain work properly at the same time, correcting misinformation I might have and stuff like that. To me, it's all one. So when my confusions go out over the video, I don't feel so bad about it in that sense. To me, it's just part and parcel of the whole thing. So now maybe some of you are free of confusion. Maybe you live perfect lives, you always think the right thing, and I have met people like that. I have met people who always have the right answer. Oh my gosh. Just a couple who I would never question anything they said. I would go away with my tail between my legs if they said something that I didn't particularly agree with. So the rest of us, let us fight our way through the confusion. So I poked around enough, messed around enough with this radio that I think I got a feel for everything I need to have a feel for. I think it's trying to dissipate 15 watts in the field coil, and I think I got to help it dissipate that 15 watts. Not in the field coil though, can't make it happen there. I would have to have a much higher B plus to drive the current through that high resistance field coil. So I need an alternate path, I need another resistor, and putting a parallel resistor in here is the right approach to this problem. What I failed to do is deal with the amount of power that's going to be dissipated in the bypass resistor. So I'm going to fish around my shop here and see what I can find in terms of resistors, maybe put a couple in parallel in there, do something to dissipate the heat as much as possible, and come up with something that I can operate and leave operating and not be worried about field coil burning out, resistors cooking the radio down here. That's my objective. And the first step along that way is to stop and drink some coffee, of course. I have hunted high and low for appropriate high wattage resistors. I have a lot of high wattage resistors like this, but they're very, very low resistance, like 3 ohms, 4 ohms, 0.1 ohms, stuff like that. So it took me a while to find another one similar to the one I have in here. This one is 2.2. Incidentally, this reading here is the reading of the resistance of the field coil. I just wanted to double check it. 1750. We'll take a look at this resistor. It's supposed to be 2.2, I think. 2.2. So I have a 2.2, 7 watt. I think this is a 7 watt or 5 watt. 5 watt, 2.2, 7 watt, 2000. Put them in parallel, going to give me about 1,000 ohms. 1,000 ohms in parallel with 1,700 is going to give me around 600. I'm going to go away and just calculate this stuff. Hey, I'm not going to do it live. I'm going to go drink coffee and calculate. Okay, I have to admit I used a website to do the calculation. So these three values of resistance in parallel, 1750, 2000, and 2200, gives you a number 660. And that's pretty darn close to 600, the goal, or what the radio apparently is looking for in the field coil. So I'm going to set this up. I'm going to pretend it's going to be permanent, so I'm going to do it in some kind of permanent way and hope that it works. Why I do the quote thing there? That's kind of weird. Okay, it's a bit of a Hail Mary move in a way. I've gone ahead and I tried to position these against the chassis, but not actually in contact with the chassis. The reason being, these things overheat and somehow their insulation should fail, then you've got B plus right on the chassis. Doesn't sound like a good idea. So in fact, these were, I could have elevated them in space and just had them sitting out here. Might probably have the same effect. I'm trying to minimize the amount of heat building up inside the radio. It's already got this guy who gets warm, and he's going to get heated by these guys, and they're going to get heated by that guy. And goodness knows where it's all going to end. It's going to be hot, I'm sure of that. So up against the chassis, of course, it's going to help the heat flow away, at least certainly initially. Once everything gets hot, though, the rate of heat flow might be quite low once everything warms up. Which means it take a while for these things to show their final temperature. Got my thermal device here. Let's get it set up and going ahead of time. This is a great thing. You can set this thing sensitive enough, if you're careful with the settings on it, that you can see cold air. It looks like smoke or steam or fog. It has kind of a foggy, kind of a more smoky color, I think. And the first time I saw it, I didn't realize what I was seeing, but you can actually see cold air, so you can look at your windows and you can see if the cold air, and I found significant cold air leaks in my house with this thing. So it's probably paid for itself a couple times over just by saving a little bit of fuel heating my house. So it's not expensive. This is an older one now. These things are not expensive. Worth having, that's for sure. Especially when you're doing stuff like this. Absolutely. But I've checked other things for heat in my house using that. Like check my oven, see if it's really telling me the right temperature. They bring food out of the oven. You can stick this thing on it and see what its real temperature, at least on the surface, is. If you're interested. Okay. No need to... and I'm not trying to push this as a product, not by any means at all. I don't do that at all. Did you know? Every day I get emails from companies wanting me to advertise their products on my channel, and I reject them all. I'm not doing that. I'm not doing that. I'm not turning myself into a filler between ads. That's not what's going to happen here. So, okay, enough of that stuff. We got to turn this guy on, let him warm up. I'm going to get a hum. This is going to make a hum for sure coming out of the speaker. We'll have to deal with that probably by upping the size of these two capacitors when we finally get to this point. Okay, any reason to delay? I still have the ammeter here, and apparently this one lead has to be connected somewhere. I think it's supposed to go right where I've been soldering. Okay, not touching the chassis. Not touching the chassis. Nobody, that's good. Nobody touched the chassis. So we're going to read the current here. 125 milliamps is the stated amount in the schematic. It looks like we've been running around 60 milliamps, about half that. And there's something virtuous about doing that too, in the sense that it just keeps everything cooler, and nothing is working as hard. Not as many electrons ripping their way out of the cathodes in these tubes, so everything would last longer. There is actually a heater temperature that if you drop your tube heater temperatures to a certain range, at that range, bad things happen. So there is on the warm-up, there is a period where the heater is crossing through a sort of a danger zone, if you like. And I don't know too much about that, but I just know there is, running your tubes cool could have bad consequences if you hit that range, whatever it is. So, any reason to delay further? No, I think I've maxed the delay here. Yeah, turn this on. Just turn this on. This is going to read the B+, and it's going to do it really well if I connect the meter. The meter is connected. Excellent. Okay, we're all set to go. I'm very hesitant. Okay, here we go. Through the dim bulbs to start off with. This is set for 20. It should be set to 200 milliamps. I think the antenna's switched off again. B+ is starting. Oh, she's going down. Now that's a low supply voltage, so that's probably the tubes coming to life, pulling down the voltage. Let's take a look at the temperature here already. There's nothing. I can barely see them. Nothing happened. Did I forget to do something? So we have a current. That's way off from 125. Voltage very low. 77 volts on the radio. It's probably just way too low. So we'll crank it up a bit here. Okay, so now we can see the current is coming up. We're still at 83 volts, very low. That little bit of current there, is not going to cause any heating effect. Still I can see them, but it could be residual heat from soldering them. Okay, let's go higher. We're at 82, so this radio comes to life around 95, doesn't it? Somewhere around there. So what I'm going to do is I'm going to turn this back, and then I'm going to give it the works. 94. You can hear the radio. Am I reading this right? This is 12 milliamps. It's nowhere near. Very little heat developing in those resistors. We're at 94 volts, so let's take it up to a little more realistic. That's 106 now. This is still way off what the radio calls for, yet it seems to be working. B plus is low. Starting to warm up a bit now. I wish I could get this on an angle. Let me do this. How about this? Getting pretty dark in here. How about this? Okay, so we got one getting red, the outside one. Temperature is 50. Just going to turn the volume down here so we don't listen to the static. They're the hottest thing in the radio, I'm sure. It's going up and up. Up around 60. So these guys can get really hot, but even at this temperature they burn you hot. At least make you snap your hand away hot. I just can't get this to come out on the camera, can I? No matter what I do. That's too bad, because it's interesting. Ooh, what's that? Quickly, somebody turn on a light. What is happening? My light's not working well. Watch this for a jump. I don't like that sound. I don't like those sounds. I don't know what they are. Went funk, and then this went up a bit. Did you see that? Let me poke those resistors. Don't touch them on the chassis. It went up. The noise went away and it went up. Just a touch. Could be everything from a loose tube. Could just be a tube that's, tube socket doing the shifty thing. I need more light in here. What have we achieved here? So the B plus is still low over here. Oh. So I'm on the 500 scale, it's still running around 160. It's kind of the same, isn't it, as it was, even without these resistors? Oh, that's not good. What happened there? Nothing happened. This went up just a touch. What happened? Where? Oh, it's back. I guess it needs its coffee breaks too. That was a little odd. This is slowly going up. That could again just be tubes warming way up. That's what that could be. Way off from 125. Am I measuring the current wrong? Can't see it. I'm measuring the current going into the wire that's going along here and reaching the top of this capacitor. What else could be wrong here? So the weird thing is the radio seems to work quite happily like this. Let's see how hot those resistors got now. Okay, so the temperature is around 90. That's not too bad. I mean, for hot. If it were 120, I'd be saying this isn't working. But at 90, now what's happening to the chassis here? You can't feel heat with your finger very well. Best place to feel heat is your upper lip. Okay, so no, don't do that, stupid. No, your upper lip is the most sensitive place to feel heat. You've probably used it and not realized it for feeling heat. But I wouldn't stick your lip. Don't stick your upper lip in a radio here. Now, that buzz we're hearing. What is that? Is that the radio? Is that the radio receiving that on its antenna? Well, we can find out here. I can take the antenna off. The answer is yes. Yeah, let's get rid of that buzz. So it's still there if I turn it up, but it's just terrible interference I suffer here. I guess we're on our way to doing another heat run test. I'll have to let this run for a while. It all seems pretty stable already, but I want to let the field coil heat up. We'll see where we get to with that. So, despite the scariness, I'm going to go in the other room, drink coffee. If something should happen here, I can smell something here. I was probably smelling those guys. Oh! What happened there? See, I think this changes with that sound. I'm not sure. That's a weird thing. Give me a stick. So I'm hitting the two bases here. Something clicked. I could always uncover, other things that aren't important doing this. No, this never stops. A weird thing during my testing the other day, when I had the power supply hooked up, these resistors heated up with the power supply, but they don't heat up now. So that's a weird thing there. I can only assume I was doing something wrong with that power supply to heat these resistors. Getting a false... Oh. Something going on here. Sounds like a loose connection to me. I'm on my way to replacing these anyway. Now, are these guys warming up at all? I didn't see any heat in them yet. I'd say no. And the temperature down here now, it's a big red blob on my machine. 100 degrees. That should shrink the shrink sleeve I've got on here. Back to tapping. Finding one thing, you know, there may be more. This has worked so many times for me, I can't tell you. Just tapping along here. In the camera it looks like I've got bright lights on this radio, but actually I don't. This is actually quite dull. It's okay, but it's not bright like you see it in the camera. Well, I thought I touched something here. It sure seemed quite indicative, but maybe not. Nope. Back to this. Yeah. Something going on with this. Probably connection problem. I can't imagine just tapping the outside here is going to cause some internal thing to take place. Okay, so heat run. Now this is just slowly going up. Not sure what that really indicates. We're hovering around 100 still. Okay, now I'm going to look at the speaker field coil, which I'm sure it's starting out cold here in my shop, or cool. Let me just do the hand thing. It's ice cold. It's ice cold, which is a good sign. Well, I think I gotta let this run for quite a while now. I think I've solved the problem with the overheating field coil, if it even was a problem. It's a problem for me. It made me worried. These guys are stable at just over 100. Now they're in the open. Of course, you lay the chassis down, they're probably going to go hotter yet. There's no air. There's no airflow through here, really. A little bit, I guess, but not enough. Okay, everything seems stable. I'm going to bail. I'll be back in a while. Well, I sat down, picked up my cup, and heard these big pops come out of here. What? Everybody stand back a bit. What was it? Nothing unusual has happened. This is still the same. B plus, still the same, very low. Put this on the 150 scale. It's over 150. Yeah, 175 is what is that? Not gonna pop for me now, are you? Here we go. Not that. the connection on this capacitor is weak. You can imagine how as it goes on and off, you'd hear loud pops in the radio because it's a B plus voltage being messed around with. Ooh. And of course it could be some internal thing in one of these capacitors, and tapping it, it's not going to do anything. This whole piece is loose here. Getting nowhere. Pop could have been anything. Even a 2-pin shifting slightly. Oh, hot diggity dog there. Hey, there we are. 34. Where are we? So if it's something like a mechanical contact and I'm poking, I could very well correct it. Ooh, now it's gone silent. Could it be the interference itself? Oh, did I do that? Am I crazy? This light is flickering. This seemed to wander up during that time. Coincidence, maybe. Because now I can whack this thing. Yeah. This guy here. Maybe that's the whole thing. Well, how come I can move it? No, I can't. So if I'm reading this right, 34 milliamps instead of 125 milliamps. That's a huge difference. According to that schematic, some of these tubes are drawing 50 milliamps. 50 milliamps. Is it 50? I think it was 50. 50. How can it be 50? Let's just take a look at the schematic for a minute and clear up something that appears to have gone awry in my head. Okay. Right here. Yeah, 4.5. Where did I get 50 from? Right there. 40 milliamps. That's 80 milliamps running through these two tubes. And I've only got 34 in the radio. It's like this just doesn't. Something is just not adding up here. It's a come and go radio. Oh. I forgot to look at the meter here during the last excursion. See? What was that? Could do the tube wiggling thing. All kinds of things could be out of sorts here. Okay, check the field coil temperature. The speaker's operating. This is the big win here. I really shouldn't look upon this as things aren't working out. They're working out really well. Starting with a radio with no speaker, I'm getting somewhere. Okay, heat run on these guys. So 112, 115, 115. That's pretty darn hot. Pretty darn hot. Hotter than I would want. Now right next to these two, I just noticed this, right next to these two resistors, in fact traveling right at the top end of them, is the power cord coming in from the wall. And got the power cord touching these 100-degree, I don't like that. I don't like that. That looks like a disaster gonna happen. I had to shut them off. Okay, so what I'm talking about here, something I didn't really notice until just now, is the end of these two resistors are right in contact with the power cord. The original power cord. Let's see if I can push it out of the way here. And what kind of temperature can it sustain? Well, it's right in contact with the wire. This is the thing. Yeah, this is bad news. It's right in. Can I push it here and get it to fall off? Oh, did somebody hear it crack? No, I just heard it crack. More work to be done. So it's stiff. I've cracked it. So this is the lead that goes up to the on-off switch. So this comes all the way back over to here. I could replace this piece fairly easily. So don't worry about it cracking right now. Just get it out of contact. Because if it shorts, you know, you got to short right into the power system. Wouldn't that be exciting? Yes, it would be. Not the kind of excitement I like. Unrestricted fault here. Well, it's hard to get it to stay out of contact. It wants to rest right against the wire coming out of this resistor. That's a 110-degree wire pushing on some insulation. That's not good. Okay, well, I'm going to have to replace this. You heard it crack anyway, and look, somebody replaced the power cord, I bet, some time ago, and they didn't do anything about the wire in here. Okay, where are we at here? Let me just check how long this video is. I've lost track completely. Well, let's take a closer look at the situation here. The radio is turned off now, and so it's safe and cooling down. Let me just switch to the other camera. Okay, well, you can see what I've done here. Here's the two resistors. Yeah. Now in the back is the wire I'm talking about. This one here, I'm following along. And if we go up where I was bending it, crack. So when it shatters like that, there's no question that this wire's got to go. It's right up against the chassis. You know, like if it's left alone, maybe nothing would ever happen. It's just going to sit there forever. But I think I would be remiss in leaving it. So there it is on the on-off switch. This is this weird on-off switch here. This guy here. See that the lever is controlled at the far end. It's in a slot here. How is it controlled? You know what? I don't even know. I guess it's being controlled by the limits of the switch in here. What a weird arrangement. Turn it off. Okay, so I got to replace that wire, and that's not a big deal. And I'm going to do that. I will do that. I'm pulling out the wire here, and it's just shattering to pieces as I go. It's just all crumbling away. It's nothing. There's nothing here. A little tricky to get it out of all this stuff. Wait a minute. Follow my safety rules here. Okay. Make sure the radio's unplugged. This is where I cut more wires than I intended. Oh yeah, it's just all crunchy here. Totally shot. How am I going to get it out of here? copper there. Yeah, copper everywhere. Holy smokes, this was really... So that's the kind of thing that you could move inadvertently and not even realize, and it maybe laid up against something, like, you know, and so just a little crack in the wrong spot. Kapowie. Okay, I got the new piece here ready to go. I need to clean that out a little bit. Okay, I'll continue working here. I thought you'd like to see the smashed up wire. That was the thing. Go. Now there's not much clearance between the connections here and the little frame of the switch. I could have soldered one of those right to the frame of the switch, which would be soldering it to the chassis by accident. Let's take a look and just see how well I did here. I see some loose strands. Well, the wire is supposed to be strain relieved under that, so I will do that, and then I'll examine it again and clean up any loose strands. Stranded wire often presents a problem like this. Let me put this up under here. Enough. Oh wow, this screw, I loosened it out, and as I loosened it out it got tighter and tighter, which is really weird. It's almost too tight to turn now any further. This just looks like a self-tapping screw. Working up a pretty good sweat on this. Go around the other way, Jim. Go under it. There's no hope. There's no way I should have fed it under it ahead of time. Why are you so tight? I've loosened it way off. Okay, I'm gonna give it the big screwdriver here. I'm gonna threaten it with this. You can't resist. Oh yeah? You can cam out though. Okay, I'll take his little brother. It's just as scary. Camming out. Oh, you tricky guy. Okay, got another one. Why did he do this? Nope, it's not going to work. You end up with a smallish screwdriver again. We'll try this guy. This guy's got a thin blade. I literally can't turn that screw. Ah, I'm sweating. all comes down to a screw today. Okay, well I'm going to put that wire in. You don't need to watch me struggle here. It's just all simple mechanics. Let's take a close look at my awkward soldering job here. What I'm interested in is, are there any shorts or propensity to develop a short? I don't think so. They don't look particularly well soldered. Very hard to see up in here when I was working. And we just crimp this one a little more and put a little more solder on it. Do the same to the other one, just crimp them and then put some more solder on them. I think that'll do the trick. Okay, let's take a look at the quality of my work here. It's not particularly good. Good enough though. There's nothing shorting, and this has now been strain relieved by this. This is the screw I was fighting with for some reason. There we go. I got the wire all laid in. Shove it back. Goes all the way along, all the way to here. This is a weird situation, but it's okay. Doesn't have the best look to it, does it? Yeah, it's probably fine, but I'm gonna throw some more solder on this. It's not. Yeah, I didn't get enough solder on it. Okay, we'll do that. Good show. Got that soldered in just fine. Now, I think I'm going to call it quits here for today, and I'm going to go forward on the assumption that what I've done here is sufficient. The radio is operating. Low B plus doesn't seem to bother it. Perhaps I'm doing something wrong with the way I'm measuring it. Can't imagine what that is, but maybe. And we'll carry on from here, probably focusing on these two capacitors, especially since one of them has shown a little bit of wonkiness. And we'll probably just get rid of these two and put something brand new in there. And then after that, it's kind of attack the wax capacitors, which I was kind of heading for some time ago until I got distracted by all this stuff. Well, thanks a lot for watching, and we'll just carry on here tomorrow. Great. See ya.